what I had there is a summary for the students who are used to teach the aminoglycosides as part of the antibiotics 1. So now, since we did not, I believe we did not do the aminoglycosides, we first now look at the aminoglycosides. Now extract streptomycin. We zero in on streptomycin because streptomycin is basically the one which is mainly used for management of TB. But aminoglycosides also is a class of drugs that we should cover. So there's no need of just going to streptomycin. I thought the best is just for us to look at aminoglycosides, and then of course we will still look at streptomycin as used in management of TB. I had sent the structures of, I hope you have them, or I hope you have printed them and you have them. So when we look at the name aminoglycosides, it gives us an idea. You have aminoglycosides, it's whereby it's telling us that these are glycosides or drugs that have amino sugars which are glycosidically linked. So amino sugars with glycosidic linkages, that's what this name is telling us, aminoglycosides. So we have amino sugars with glycosidic linkage. And examples of these drugs include kanamycin, neomycin, gentamicin, tobramycin, streptomycin, amikacin, and I think, yeah, those are basically almost all of them. I think there's paramomycin, which is not there, but we look at most of them: kanamycin, neomycin, gentamicin, tobramycin, streptomycin, amikacin, with the exception of amikacin, but you can still see the CIN in all of them. So you can see their suffix has similarity, meaning they have some similarity. Indeed, they have structural similarity, and they also have a similar mode of action. So you have similar mode of action as protein synthesis inhibitors, and also they have a lot of structural similarities. Of all of them are aminoglycosides. They could have different amino sugars, as we are going to see. They can have different amino sugars. They can have differences in the way the amino sugars are linked to each other, but they have structural similarity, and also they have a similar mode of action. This one going so far to that side, like it can't reduce. So introduction, the aminoglycosides, aminoglycosides are also known as aminocyclitol. When you talk about a cyclitol is a six-membered. Cyclitol is a six-membered hexane ring with a lot of hydroxyl substituents. So a cyclitol is different from a sugar. A sugar has an oxygen. A cyclitol is a hexane. So a hexane. So we call them the aminoglycosides or aminocyclitols. You will see as we move on why are we calling them aminocyclitols. So the aminoglycosides or aminocyclitol class of antibiotics contains a pharmacophoric 1,3-diaminoinositol moiety consisting of either streptidine, streptamine, 2-deoxystreptamine, or spectinamine. And when we talk about the aminocyclitol, is what we are saying here. It's a cyclohexane with several substituted or and hydroxyl group, which brings them high water solubility. So when you talk about an inositol, aminocyclitol or inositol, it is a cyclohexane with several substituted hydroxyl group, amino groups at different positions, but you can see it's a cyclohexane. So it has 6 carbon atoms, cyclic, all joined together, cyclic. It's a cyclohexane. And at different positions, it has amino groups, and it can also have hydroxyl group. You can see we are saying some of them contain 1,3-diamino, meaning at position number 1 and position number 3 of the inositol, which is a cyclic hexane, you have an amino group at position 1, you have an amino group at position 3. That is one type. And then you have the other, we have also another one which we are going to look at. So pharmacophoric 1,3-diamino moiety consists of either streptidine, streptamine, 2-deoxystreptamine, or spectinamine. We are going to look at them at the moment. I mean, in a minute. So all this, when we talk about streptidine, when you talk about streptamine, when you talk about deoxystreptamine or spectinamine, they have a specific structure. And what we are saying, they are cyclohexanes. And we have mainly 2 of them. We consider the one we are talking about here, which we are calling the 1,3-diaminoinositol or you can have the one called the 1,3-diguanidino, or the 1,3-diamino-inositol. So you can have show you the structures. So we are looking at this and we are saying this is the streptidine, this is the aminocyclitol or the inositol. That is the streptidine, and this is what is found in streptomycin. This, if you look at it, it is, if you look at position 1, a carbon, position 2, carbon, position 3, carbon, position 4, carbon, so position 5, carbon, so 3 carbon, position 1, carbon, position 2, carbon, 3 carbon, 4, 5. So you can see these are cyclohexane. But if you look at this cyclohexane, that's what you're saying. It has substitutions at several positions. Like if you look at position 4, hydroxyl group, position 5, hydroxyl group, position 6, hydroxyl group, position 2, hydroxyl group. So in 4 of its positions, it has hydroxyl groups. Then if you look at its position 1 and 3, it has some similar substituent, which we are calling the diamino or the guanidino amino moiety. So it's the one we are calling here the diamino, calling it the diguanidino and 1,3. So that's the 1,3-diguanidino. So there are 2 of them. So guanidino. So this, if you look at this is a guanidino moiety, that one there, and at that position, we also what we call, even this one we are calling it the guanidino moiety. And because they are 2, we call, of course, that's why we are calling them diguanidino, and they are 1 position and 3 position. When you look at the structure of streptomycin, this is the inositol, this is the cyclitol that is found in streptomycin. As I have said, the aminocyclitols are cyclic. Of course, they are cyclohexane moieties that are substituted at several positions with either hydroxyl groups or amino groups. For streptidine, which is found in streptomycin, it must have that structure. Now, the only thing we are going to see is how is this now linked with the amino sugars, because we said the aminocyclitols plus amino sugars glycosidically linked. So streptomycin, for streptomycin to be streptomycin, it must have this aminocyclitol, which is streptidine. Then we have the other one we call streptamine. For streptamine, it is the one we have said it has the 1,3-diamino. So it has one, at position 1, it has an amino group. At position 3, it has an amino group. And all the other positions are substituted with hydroxyl groups. Then you have the 2-deoxystreptamine, and this is what you find in most of the other aminoglycosides, except of course streptomycin. Streptomycin, you have streptidine, and you can see the only difference between 2-deoxystreptamine and streptamine is that the position 2 here of 2-deoxystreptamine is not substituted. And as when we look at most of our aminoglycosides, of course, with the exception of streptomycin and of course also tobramycin, you find that they have this 2-deoxystreptamine. They do not have the streptamine, they have the 2-deoxystreptamine. Then you have the spectinamine, and when you look at spectinamine, again at position number 1 and position number 3, position number 1 and position number 3, you have the methyl amino group. Again, at that position and that position where you have, I have not seen this in any of the drugs, but we will see that one. You see, definitely we see this one, you see that one and that one. So now, if you understand those aminocyclitols, we are saying those aminocyclitols are joined glycosidically to the aminoglycoside. So let us look at an example, which is kanamycin, just for us to understand what we're talking about. If you look at this is a drug we are calling kanamycin. There's kanamycin, you can see this is an amino sugar. It has an oxygen there. That is an amino sugar. It is an amino sugar because when we look at the substituents at R1 and R2, one of these substituents, this is R1 here, that's R2. One of this must be an amino group. So that's why we are calling them amino sugars, because for sure, this is a sugar. That is a sugar. Now, when you substitute it with an amino group, it becomes an amino sugar. Then, and also if you look at this is an oxygen, this is an amino sugar. Again, you can see at position 3'', there is an amino group. So this qualifies to be an amino sugar. If you look at this, is calling our aminocyclitol. This is aminocyclitol or inositol, because look at it. It is a cyclic, it is a hexane ring. This is a hexane ring. But you look at position number 1, it has an amino group. You look at position number 3, it has an amino group. You look at position 2, it has no substituent. At position number 5, it has a hydroxyl group. At position number 6, it had a hydroxyl group, but that hydroxyl group, which has this oxygen, has been linked with the amino sugar glycosidic bond. This is a glycosidic bond. Again, at position number 4, the aminocyclitol has been joined or linked with the amino sugar with a glycosidic bond. So if you look at this, this is 2-deoxystreptamine. This is 2-deoxystreptamine. It qualifies to be 2-deoxy because at that position, you can see the hydroxyl group has been removed. At position 1, it has an amino group. At position 3, it has an amino group. It is a hexane, a cyclohexane ring. At position 5, it has a hydroxyl group. At position 6, it had a hydroxyl group. It is only that it has been linked with the amino sugar. At position number 4, it had a hydroxyl group. So indeed, this ring here is streptamine, is 2-deoxystreptamine, and it is the one which is joining. It is used to join. It is at the middle, joining the 2 amino sugars of kanamycin, the 2 amino sugars of kanamycin through glycosidic bonds. So that's kanamycin. Just wanted to stress that point so that it gets into our mind. Then you have another one like tobramycin. Again, you can see this sugar is the same. Sugar is the same there. 2-deoxystreptamine, 2-deoxystreptamine there. The only thing that will differ in tobramycin is that these sugars will be different. They will not be the same as the sugars. One could be different. They will not be the same as those found in kanamycin, just to make that drug a little different. Then that is tobramycin. Then you have paramomycin. Now, if you look at paramomycin, this one adds some more differences. This one has a ribose sugar. The others you saw, they had 3. They had 2 amino sugars. This one has 3 amino sugars, one of them being a ribose sugar. Different. So look at that. That's an amino sugar there. An amino sugar. You can see that's an amino group, qualifying it to be an amino sugar. And then if you look at this structure here, it is 2-deoxystreptamine. So that amino sugar linked to this aminocyclitol or the inositol through glycosidic bonds at position number 4, and then at position number 5, again linked through glycosidic bonds to the ribose sugar. And as we have said here, there's a slight difference that we also have the ribose sugar again linked to a third amino sugar through glycosidic bonds. So what we amino sugars glycosidically linked. So you find that they do have amino sugars that are glycosidically linked. And of course, paramomycin has 4 rings as opposed to kanamycin, which has 3 rings. So those, when I bring you another example, this is neomycin. So again, neomycin, like tobramycin, paramomycin, neomycin like paramomycin, has also 4 rings, and it still has a ribose sugar. Again, as we said, the differences will be within these rings. What type of ring is it? And it will differ slightly with the substitution. So again, you find it has the ribose sugar. It has, that is your amino sugar there. This again is your 2-deoxy. You look, see, as I said, repeated streptamine, again glycosidically linked with the ribose sugar, and then the ribose sugar again glycosidically linked to the amino sugar. So again, so paramomycin and neomycin have that structural similarity in that there are some examples of the aminoglycosides which also include a ribose sugar. Then you have, we are only looking at them just to appreciate what we are saying. So when you look at netilmycin, again you see, although there is introduction of unsaturation there, this is still an amino sugar there. And this is another amino sugar there. And then 2-deoxystreptamine streptamine. I think now the one we need to look at is streptomycin. Now here is our streptomycin. When we come to look at streptomycin, we even find the arrangement of the amino sugars and the aminocyclito is a bit different. In the others, we are finding that the aminocyclito sandwiched in between. The amino sugar is sandwiched in between. But when you look at the streptomycin, you find that the aminocyclito or the guanidino moiety is the one you start. It's a starting ring, and then glycosidically linked to the 5-membered ring sugar, and then that sugar is again glycosidically linked to another 6-membered sugar. So there is a difference in the arrangement of the component of streptomycin when we compare streptomycin with the other aminoglycosides. That is important. First, it's important to note. Again, even when we come to look at this ribose sugar, we will see there is a difference between the ribose sugar that is found in streptomycin compared to the ribose sugar that is found in the others ones that we have given as examples, neomycin and paromomycin. So there is some structural difference in the sugar, in the 5-membered sugar, and indeed the one which is found in streptomycin is called L-streptose. Now, of importance that we need to note is, of course, arrangement is different, and of course, even the type of the aminocyclito, as we can see it here, is different. I told you in streptidine, the aminocyclito is in streptomycin, the aminocyclito is streptidine. In the other ones, it is 2-deoxystreptamine. So in this is, of course, streptidine. You can see it's your 1,3-diguanidino. So you can see this is a guanidino moiety. So that's the other difference that you find in that drug. The final difference, final molecule which has some structural difference. I hope I was thinking I have it. Spectinomycin. I'm looking for spectinomycin. No, it is. I was thinking I have spectinomycin. The only other molecule that has complete structural difference but still has aminoglycosides and also has the aminocyclito is spectinomycin. Spectinomycin is a molecule where the groups are fused together. They are fused together rather than being joined with through glycosidic bonds. You find that they are fused together. There it is. Yes, that's what I was looking for. So if you look at spectinomycin, I hope you can appreciate the difference. There is a difference. So you can see it has the spectinamine. This is the aminocyclito. The aminocyclito is, remember we said, it's a cyclohexane ring substituted with amino groups and hydroxyl groups. That is what and of course is what we are calling the aminocyclito. And then if you look at it, this is our sugar here. This is our sugar at this point there. So this is our sugar there. This is our amino or inositol. So if you look at it carefully, you will see all that has happened is that this second ring here is where the glycosidic bonds, this is a glycosidic bond, this is glycosidic, but they are fused together. There is fusion, so that you can see like you have formed a tricycle. You have three rings fused to each other. If you have to look at it, you could say you have that ring and you have this ring and the other one. But this middle ring is just the fusion brought about by the fusion of the glycosidic links, because you can see this is a glycosidic linkage and then it comes there, and then this here is a glycosidic link, and again it is fused to this ring. So of course, this is a substituent hydroxyl group. So if you look at this here, starting from here, coming this way and joining to this point here, that is a glycosidic link. You look at this side, starting from this point, coming this way, so the glycosidic links are being used to join, to fuse. Actually, they're being used to fuse the aminocyclito and the amino sugar together. So the aminocyclito and the amino sugar are fused together, but still through glycosidic links. The other one, there is no fusion. Each ring is on its own, and the joining is through the glycosidic bonds. So nevertheless, you can still see even this drug, although it has that small structural difference, and of course you can see there's a ketone there. There is that small structural difference, but there you can identify the fact that you do have the aminocyclito or the inositol, and you do have your amino sugar, but the two are fused together through glycosidic bonds, unlike in the others where they are joined through glycosidic bonds. Of course, also when we look at this drug, we see, unlike all the others, it is the one with the least number of rings. It has only one, and of course, all of them have one aminocyclito, and none of the other, all the others have a minimum of two. But spectinomycin, which was sometimes back very, very popular for syphilis as an injectable, then you can see it has a structural difference where the two rings, one are fused to each other through glycosidic bonds, and of course it has one amino sugar, and unlike the others which have 2 to 3 amino sugars. I have decided to go through that so that now when I talk about the aminocyclito, I hope now you have understood when we say it can be a guanidino moiety, it can be a guanidino derivative, or it can be a 1,3 guanidino derivative, or it can be a 1,3 amino derivative with retention of activity. Because once you understand that bit, yes. Now we go back. I just wanted us to look at all those structures so that you appreciate terminology, aminocyclito. So that's where we are. That you appreciate what we have said here. You know, if you try to explain fast without having looked at the structures, it becomes difficult. But I hope now we can appreciate this slide. The aminoglycosides or aminocyclito class of antibiotics contains a pharmacophoric 1,3 diaminoinositol moiety, and we have said the inositol is the same as the aminocyclito. Inositol is that moiety which is cyclohexane substituted. The aminoinositol moiety consisting of either streptidine, as in streptomycin, streptamine, I don't have an example, 2-deoxystreptamine, or the others that we have looked at, all spectinamine, where we have the spectinomycin. So it's streptamine, we do not have an example. And we are saying the aminocyclito or the diaminoinositol are cyclohexanes with several substituted or unsubstituted amino. You see, if you look at some of the drugs, like if you look at, when we look at the structure of gentamicin, you will find that the amino group is also substituted. That's why we have said they can be substituted or unsubstituted amino groups. Like if you look at kanamycin, the amino group is not substituted. When you go to gentamicin, you see the amino group is further substituted with a methyl group, and we'll discuss the advantage of that substituted. So please understand this statement: substituted or unsubstituted amino, and then hydroxyl groups, which brings them high water solubility. When you talk about amino groups, and there are so many, that molecule will have very high water solubility, and no wonder all the aminoglycosides are given parenterally. None of them has oral activity because of the very high water solubility brought in not only by the not only by the amino or the inositol molecule, the amino inositol, but the fact that even when you look at the amino sugars, even the amino sugars have a large substitution of hydroxyl and amino groups. So the large substitution of hydroxyl and amino groups make these drugs highly water soluble. So even if you try to give them orally, they will not be absorbed. They will not be absorbed because they do not meet, or they do not have the necessary lipid solubility for them to penetrate the membranes. They have very high water solubility. They will go into the solution and just live with the feces without being absorbed. Streptidine and streptamine can be called streptidine and streptamine can be called 1,3-diguanidinol for streptidine and 1,3-diamino inositol respectively. So this is the 1,3-diamino, and that is the 1,3-diguanidinol. And as we are saying, we also refer to the cyclitol and inositol are kind of interchangeable. So we are saying we can call them streptidine and streptamine can be called 1,3-diguanidinol and 1,3-diamino inositol. So they have, so that the amino cyclitol is also what we are saying is a substituted inositol. And of course, now I hope that is clear. We have already looked at that. If you have any questions, please raise them. We are saying several of the alcoholic functions of the 1,3-diamino inositol are substituted through glycosidic bonds. So not really several, mainly two of them. So two are substituted with either, so two of the inositol are substituted with either amino or guanidino. Then two others are substituted with glycosidic bonds, leaving us with one, because the other one, in most of them, they are leaving us in one in most of the aminoglycosides, because most of them, we said, they have the 2-deoxy, but in, of course, streptomycin, leaving us with two, which have the hydroxyl group. So we are saying several alcoholic functions of the 1,3-diamino inositol are substituted through glycosidic bonds with characteristic amino sugars to form pseudo-oligosaccharides. When you talk about pseudo-oligosaccharides are like pseudo sugars, they're not pure sugars. They are sugars that have, or they are not we cannot call them true. They are kind of not true saccharides because they have between 3 and 9 sugars. And I think the saccharides should have more sugars joined together. So we are saying they are joined. The amino inositols through glycosidic bonds will be joined to they'll be joined to amino sugars through glycosidic bonds. And that's why we are saying they form what we call the pseudo-oligosaccharides. That means they can have between 3 and 9 sugars. There are some which have 3, the others that have 2. And we have examples of carnosamine as 1. Carnosamine is an amino sugar. Niacinamide is an amino sugar. Garasamine is an amino sugar. These are very specific amino sugars find in the respective or in the specific aminoglycoside. Carnosamine you will find in kanamycin, niacinamide, in neomycin, garasamine, in gentamicin. So we are saying there are those specific amino sugars, and those specific amino sugars glycosidically linked to the inositols, and they can be one. We have seen they can be a maximum of 3. Antibiotics contain, so we can't say the aminoglycosides are antibiotics that contain an aminocyclitol. We have already explained what aminocyclitol is, to which amino sugars are glycosidically linked. So I hope now that is very clear. We are saying they are antibiotic containing an aminocyclitol, which is a cyclohexane ring substituted at specific positions with amino derivatives, and of course also with amino groups, also with hydroxyl groups, to which amino sugars are glycosidically linked. They may be more correctly called antibiotics. So I hope you can be able to explain why we are saying these aminoglycosides can also be known as aminocyclitol antibiotics. And of course, now we have looked at the examples, and we are saying, we look at this is what we're calling our carnosamine sugar. That is our carnosamine sugar. You can see at position 1 prime prime. We're going to look at the positions. When we start numbering from our streptomycin. So we are starting with our streptomycin. Starting with our streptomycin carrying position. This, of course, is our deoxystreptamine, our inositol, that's our aminocyclitol. That is where we are giving the numbering, because that's number 1, and that's why we call it 2-deoxy. Number 2, and position 1, there will be an amino group. Position 3, there will be amino group. Position 4, glycosidically linked to our first amino sugar. Position 5, a hydroxyl group. Position 6, again glycosidically linked to our second amino sugar. So this, the aminocyclitol or the inositol or the aminocyclitol is the one which is carrying position 1, 2, and then we go to this ring. This is an amino sugar. It carries 1' where it joins, where it's glycosidically joined to the aminocyclitol, or to the inositol, where it's glycosidically joined to the inositol. It carries its 1', and then, and of course, you can see it's always next to the oxygen. 1', 2', 3', 4', 5', and then, of course, the inositol is also joined on the other side to another sugar for kanamycin, and of course, that sugar carries now, where it is joined again, always next to the oxygen. You carry 1', 2', 3'. So that's how you differentiate which sugar or which ring you are discussing. So you have, when you come to number them, you just go in the proper order. The first ring is given number 1, second ring number 2, and the third ring number 3. So we can't see, when we again remember, just as we said of the rifamycins, these are naturally occurring compounds, and they occur as mixtures. They occur as mixtures which differ very slightly. So if you look at like kanamycin, you have kanamycin A, you have kanamycin B, you have kanamycin C. If you look at kanamycin, all these, this and that will be the same. Where we will get a difference between the various kanamycins A, B, and C is at position 6' and position 2'. So you can see for kanamycin A, R1, which is at 6', is an amino group, and R2, which has 2', is a hydroxyl group. Again, when we are looking at the SAR, we will come back to see whether the substitution of an amino group here or there, whether the substitution of the amino group and or the substitution of the hydroxyl group has any influence on biological activity. So yes, kanamycin A has an amino group at position 6', and at position R2, at 2', it has a hydroxyl group. Kanamycin B has an amino group at position 6', an amino group at position 2'. And then kanamycin C is a reversal of kanamycin A. So it will have a hydroxyl group at 6', and an amino group at 2'. So as I have said, please note that point. We're going to discuss when you're doing the SAR. We mentioned those and be able to see whether they have any influence on biological activity. So again, these are naturally occurring compounds. You can again see that the area where you are doing structural modification is a very small area. Even in the naturally occurring compounds, it is only ring 1 where you are doing a bit of structural modification, and you can get the different within the same mixture, which or within the same fermentation mixture, you get kanamycin, and to exist as kanamycin A, some of it will be B, and the other will be kanamycin C.